This is a video about AC Motor CAD's polyphase induction motor design program called Vica 30. To start, we bring up the Vica 30 Excel spreadsheet. And the name of this one is going to be C4756. You can name it whatever you want when you're done with the design or in the middle of a design. So this is the main tab with all the design information on it. You have titles, you have motor specifications. Column C is where the design information goes. And you leave the rest of it alone. There's a bunch of calculations and stuff over here, but you won't have to be too concerned with that. So this design is a 12 and a half horse, 4-pole, 60 hertz, 460 volt motor. And these design parameters are from Vic's program in the 1980s and 90s, when many people were working with this on a DOS operating system. And now this will run on Windows. The program is separate from this spreadsheet. This is an interface to the program. So you put your major parameters in here. Your stator parameters go in the green area. This is a slot type 2, OD, ID, slot count, etc., etc. Same data that used to go into Vic's DOS program. And here's the winding detail. Here's ground wire. You can use rectangular wire. You can use concentric windings. This pink area is the rotor information. Slot type 14, rotor OD, ID, skew, ducts, slot dimensions, and now we have some convenience parameters, which, for instance, it calculates the air gap for you, but this isn't where you put the information in. This is some information that you might want out. Anyway, the diagrams are the same as that was in the VNOT book. You have all these different parameters that you put in. And it makes a sketch from the parameters in this column and the information about the diagrams, which is pre-programmed. So the sketch is very handy for checking what your design looks like. Now it's September 25th, and after this video was made, so I've added a picture that shows the side view on the sketch. That's what it does now. You won't see it in this video, but you can see end rings on here. They're misplaced. You can see the end rings on the side view as well. And it shows you the value of the sketch because you can find gross errors like this. And this geometry is linked to column C in this spreadsheet. For example, instead of having let's change something to show that. Instead of having I don't know how many, no, we can't double the number of slots. Let's make this slot a lot deeper, Okay, this is that will be easy to show. So you're showing about well, about 2 squares deep here. Let's double that. So being familiar with VNOT's program, you go to the PR dimension for the slot depth, rotor bars, tip depth, mouth, total depth, PR 0.478. Remember that number. So let's go to 0.9. Now, to get the new sketch, you use this tab up here, AC MotorCAD, and the icon is to redraw. Now you can see you've got double the slot depth. I hope it was that's the number I remember is 0.478. Oh, I'm not. All right, but these numbers here are yellowed out because I don't have a bottom cage in a type 14. If I had a type 26, and now we'll run the Vica 30 program by clicking that icon. That's how fast it happens. This is the old DOS program in disguise, adapted to Windows 10, and with a lot of improvements over the old program as well. So now that we've run it, we can import the data with this icon, which will show. No, that's not it. Yes, it is. Shows the output tab with the latest data. This is Vica 30N as in Navy. I have to change this. So I've got an L in there. So I will go get the data. And you want to see this done here so that you know nothing went wrong. This, you can look at the data and it shows the current date and time. It is 6:48 a.m. right now. And from this data, um, the here is the normal printout from Vica 30. It's on a disk file now, and it's just read into this tab. And here's the load performance. Here is the speed torque curve. There's a lot of points now because there weren't enough before. And then other stuff. The load performance data has been extracted to a separate tab, and the speed torque data has been extracted to a separate tab. And the columns here in these sheets are used as source data for the load performance chart and the speed torque chart. So that's very slick. If you want to change it, now let's remember, let's say at 100 or at 100%, we go through just over 1200 amps. So let's go change it and demonstrate how this could work again. Let's say I change something. Let's do that trick we did before where we extended the depth of the slot to 0.9. Rerun it. Check. Okay, let's run it. Let's import this data. See what we got. Whoa, it's not a very, well, guess what you want your motor to do, but it's definitely not 1200. It's half of that because the reactance doubled just about. So let's go back to where we're supposed to be. 478. You always, you're safest to redraw it before you hit the other icons. Otherwise, I remember having trouble with that. Back to normal. Rerun it. Import it. You can see you don't have, if you don't import, you're going to have the old data in these tabs, in these sheets. So we'll get the new stuff. That's better. Okay, so that's the basic operation. You keep tinkering with dimensions until you get what you want, but that's always been the way it is. But we have an optimization tab now. You can optimize the design based on efficiency or stator temperature rise, which this is a simple, brainless stator temperature rise calculation. It's not real. It's not. I mean, it's not accurate. But you can put in your own equations for that, and I guess this is the weight objective function. You want it to be less, obviously less than 6 something pounds, I guess. We're in English units, and it doesn't help you if you're until you're in this 6 to 7 pound range, for instance. You can define your own curves for figures of merit, these various optimization things, and that's very handy for getting a design that works quickly. But most of you will start out just doing it the way I've shown so far. Um, you have steel grade charts now where, whoop, doggone mouse. This is the sheet for steel grade 1. It also shows the curve on here for comparison for steel grade 2. See, the information for this comes from these columns. This was what was in the code that BNOT had. I was playing around with that. You can have up to 99 steel grades, but you can only use 2, of course. Here's a wire table. You can use whatever wire table you want. And sketch diagrams, user equations can be handy. You can define user equations so you can get things like weight, temperature rise, cost, etc., and they will print out on your in the printout, the output here. More about those later. If we want to go look at the program files, I'll save that. By date, I just saved this. We've always got a diagnostics file. Here's the output. Yeah. We've always got the output file. It's a text file, and it's the same thing you saw in the spreadsheet where it was imported. That's all of it. And then, like I said, you got 200 or so speed torque points, and you got 45, I guess, load performance points here, and then some other stuff, the inputs, and yeah, input data. Where's your input data come from? Well, it's Vica 30 input, which is written by Excel when you click the run icon. And it's a lot simpler now. You don't need any more punching files. They're a thing of the past. Thank goodness. And all these variable names are just copied from column B, and the values are copied from column C, and that's all it does. Now, of course, the Fortran program has been rearranged so that it reads these instead of the old cryptic uh, input files. It always reads from Vica 30 input.txt. So if you want to save that, I don't know why you would if you save the spreadsheet, but if you don't save the spreadsheet, you can save this as, you can copy that to, and then you can rename it to something else, whatever you want. These are text files, they're editable with Notepad. You notice that's what opens these. The optimization parameters when you need them, and the user equations when you need them are written. This was when I was messing around with finite element analysis. That's not an available feature. Maybe someday in the future. It takes a lot of work. Diagnostics. Output I showed you. Like 30. Here's the program itself. So if I double click that, it's the same thing Excel did. Nothing magic about what Excel, how Excel interfaces to it. It just shells out to that exe. That's all it does. And then you can see now it's 702. The dates on these things changed to 702, the ones that were rewritten. And you've always got your date there in the output file. So it's helpful to check that sometimes. That saves me from trouble now and then. And other files that the program uses are the steel files. Steel grade 1. It's just a bunch of pairs of B versus H. And those units, I think you can change the units. So more on that later. That's for grade 2. And here's the user equations that got written from the user equations tab in the workbook. I don't know if any of these are used or not. Yeah, that's used. They're auxiliary files. You won't have to mess with them. So that's a demonstration of Vica 30 for Windows and with the modern version of Excel. Thanks for watching.